troubleshooting today. Now, I said in one of the classes we had before, I said it's not enough to just build a network. What do you do when there's problem on the network? And that is why each and every technology we've learned, all these technologies we've learned one after the other, we need to learn how to troubleshoot those technology. That's why after today's class now, I'm going to now send you guys labs that has to do with troubleshooting. For instance, now we did VLAN. We did VLAN and inter-VLAN routing. There will be a lab on VLAN where things are not working the way they are supposed to work. I will send you guys the lab on troubleshooting. Sorry.
Okay, sir.
Yeah. So sorry. So there's a lab. Almost all the technologies we've done, they have labs that has to do with troubleshooting. So in case you run into trouble and then you need to know how to fix the problem, or you need to know how to troubleshoot a particular technology. So this chapter is just a general knowledge on troubleshooting, a general knowledge on troubleshooting. But the other technology we've learned, anyone that has a lab on troubleshooting, I'll send all the labs. That's why this thing we are doing here is not a race, it's a marathon. As in, you go step by step by step by step. So that by the time you are done, if you tell somebody that I am a CCNA, you talk with confidence. They know that you know that you know that you know that you know these things. And troubleshooting is part of the skills that you guys need to acquire. That is very important. So let's start the ball rolling. So this chapter, network troubleshooting. What are the things we need to know about troubleshooting in general? Please, in case you are not hearing me, just talk so that I will know I need to troubleshoot my network. So the objectives for this particular chapter is the objectives we have going to talk briefly about network documentation. We're going to talk about troubleshooting process. We're going to talk about troubleshooting tools, symptoms and causes of network problems, troubleshooting IP connectivity. Now, when I'm done with all this theory stuff, I will also talk to you guys from my own little experience on troubleshooting the network briefly, which most of the time that's what you come across. But let's go through some of the theory to see what they have to tell us. So the first part is network documentation. What do we need to learn about documentation? We need to document our network. Now, one of the reasons why you need to document the network is because it does not only help you to troubleshoot when you run into trouble, it also helps the organizations in case you leave the organization. Take, for instance, you have 5 routers, maybe 20 switches in your organization, and Rex happened to be the senior administrator or the senior network engineer, and he left the company to another company, and they hire a new person, and the new person doesn't know where the routers are, where the switches are, so it becomes a challenge for the new engineer. But if there is documentation, all the person needs to request for from the organization is, can I have the documentation? Looking at the documentation alone, the person will be able to tell, okay, this is the topology of this network, this is the physical topology, this is the logical topology, these are the where the equipments are located. So all of these details are going to be captured in the documentation. That is why documentation is very, very, very important. And there are some tools out there that can also help in doing this documentation. In Nigeria here, let me say around the people that are some of the people that I've seen, people don't really take documentation serious. But for what I've gathered from people that are working in the UK, like Kunle that I brought to the platform the other time, I got even Coyote too. I gather that from them that documentation is very important in any organization. So we are going to talk briefly about documentation. So documentation overview. Accurate and complete network documentation is required to effectively, can you see that? To effectively monitor the network. and also to troubleshoot. So we need to have accurate documentation. We need to have complete documentation. So what are the things that are going to be in our documentation? In the documentation, you're going to have what we call physical and logical network topology diagram. We're going to break them down. We're going to have network device documentation that records all pertinent device information. And we're going to also have network performance baseline documentation. These are all the things you need to have in your documentation. This is at least minimum. So that when you run into trouble or when you're monitoring, all of this information will help you in doing your day-to-day job. All network documentation should be kept in a single location. All network documentation should be kept in a single location. And backup documentation should be maintained and kept in a separate location. Why do you need to separate the locations? If anything should happen to the one in one location, at least you have another one in another location. Take note of that. So this is a network topology diagram. The one on the left here is the one on the left here. The one on the left here is what we call physical topology. And the one on the right here is called a logical topology. What is the difference between the two? When you talk about physical topology, it's talking about actual physical connection between all your devices, including the locations. You can see this router here, the name of the router, where the router is located, the room where it is, another router, where it is located, the room where it is. All of these details are captured in physical topology. But we need to go beyond that and capture some other details about our network. Like what? Like the IP address connection. Look at the IP address between this central router and the ISP. The IP address between this router and my server here. So by the time you begin to include the IP address connection, the network addresses, the address on the interface, major stuff like that, the VLAN information that you have, that is referred to as logical topology. So your logical topology does not really talk about the location where things are or how they are physically. It also shows you how they are physically connected, but I'm talking of mainly the location where they are, but it goes beyond that to show you about the IP addresses and network addresses of the devices. So these two have to be captured. Now, why do I need the two? If I am a new engineer in an organization, all I need to request for is this network topology diagram. From the physical topology, I know where the equipment are located. From the logical topology, I know the network connection between all my devices. I know the network addresses. I know the IP addresses on all of these things. I know the LAN that I'm working with. I know that I have Ether channel running somewhere here. With that, I already have 80% understanding about that network. But if I don't have access to this, or this is not available in the first place, you are going to be in a serious mess asking questions about where are your routers, where are your switches, what are the configuration done between these devices, and so on and so forth. So that is very important. We need to go beyond what we got here by doing further documentation about these devices, each and every one of them. Network device documentation should contain accurate, up-to-date record of the network hardware and software. So when I have a router, if I have a router now, what is the capacity of my router? Like, look at it now, the model of the router, description about the router, where the router is located. Now, this is the device, the model, description, location, and the operating system running on the router. If I come here now, these are the interfaces on the router, the interfaces, the description on the interfaces. Now, remember that when we are doing configuration, we talk about how you can use description to point to indicate the network or the connection let me see, the location a particular port leads to. So you can see the IP address on the interface, that's IPv4, if it has IPv6, and also the MAC address of the router, if it is running any routing protocol. We need to capture all of this, device by device, device by device. Look at the switch here. We have to capture the device, the name of the switch we gave, the model, the description, the IP address, that is the management IP, the operating system is running. If it's running something called VLAN trunking protocol. We didn't do VLAN trunking protocol because they removed it from the CCNA. I don't know why they are mentioning it here. Okay, so now coming down here, we can see the major ports are captured, not all the ports. Major ports on the switch, like the ports that connect to the another switch, the ports that connect to the router. The ports that are connecting to the host are not really captured here. So because you could have a switch of 48 ports, it may be cumbersome for you to capture each of the ports and say this connect to office A, admin office, this connects to this office, this connects to that office, and so on and so forth. So you may skip all of those ones, but just concentrate on the major connection between devices on the network. Then you can indicate whether it's an access port or not. Also, look at in this place now, we have some ports that are not in use. We have to indicate. Then look at this one, they indicated as an access port to user. You can let us know whether you are running VLAN on the switch, whether the dial is trunking, if you have Ether channel, if the native VLAN that you're running, and if the device is enabled. These are some details you need to capture about your devices. What about the end system documentation? Major ones. Because if you have a big network where you have like 7,000 computers, 15,000 computers, you cannot document everything. But if it's a small network, you can go through the pain of documenting on each of the systems, like 30, 50 systems if you have the time. So you can tell about the devices, the operating system running on them, major ones in particular, like your servers, their MAC addresses, their IP addresses, their default gateway, and their DNS address. These are network device documentation. So the third part of this documentation we need to talk about is establish a network baseline. Establish a network baseline. So what is a network baseline? A network baseline is used to establish a normal network performance. To determine the personality of a network, I like this word, to determine the personality of a network under normal conditions. Establishing a network performance baseline requires collecting performance data from the ports and devices that are essential to network operation. What are we trying to talk about here? I need to understand the behavior of my network. I need to understand my router's usage. What I mean by my router's usage is this. On a good day, maybe from morning till evening, what is my CPU usage? What is my RAM usage? What are my interfaces usage? With all the traffic going through to and fro, I need to have all of this detail. And the reason why I need to have all of these details is in case or suddenly I just realized that my router that does not go beyond 40%, the CPU does not go beyond 40%, is now eating 80%. I will know that something is wrong somewhere. Maybe we are under attack. Or maybe my RAM that does not go beyond 50% or 70% is now going towards 100%. I know that that's a problem somewhere. Or the interface is something is going on. The traffic usage is becoming high unnecessarily. As soon as I notice this abnormal behavior concerning my network, I need to get to work. But if I don't know how my networks behave in the first place, I won't be able to tell about this abnormality. Or let me say, if I don't understand the personalities of my network, if I don't understand the personality of my network, I wouldn't know when other things are happening. So we need to establish a network baseline. So in establishing networking baseline, you need to understand the behavior of your network, the behavior of each of the devices. What is your bandwidth usage every time on the network, and so on and so forth. So the baseline data is as follows. Provide insight into whether the current network design can meet business requirements. You need to, of course, we talk about hierarchical design. You must be sure that what you got can meet the requirement of the organization. And you can reveal areas of congestion or areas in the network that are underutilized. You need to understand them from your network baseline. If, for instance, the area that are underutilized, you suddenly notice that things are going higher than normal, then you may be able to, you may start suspecting some stuff here. So let's go through different steps. Okay, let me give room for question in case you guys have questions based on these small things we've discussed.
No questions, sir.
Are we flowing together?
Yes, sir.
Where is Rex?
So the last step is like establishing network baseline. It means it is done when the network is already
When the
established.
network is up and running, you take all of this baseline, and we're going to talk more on that. In taking baseline, what are the things you use in getting a baseline? We're going to talk more on that. I just gave some example, like, you need to understand the personality of your network, the devices on the network, the bandwidth usage on the network, how the network behave on a normal circumstance. And there are tools that will also help you to do some of this analysis, and we're still going to talk about some of those things when things are going on well. Is it clear, Rex?
Yes, yes, sir.
Good. So now, let's go through different steps in this our network documentation. Step 1, determine what types of data to collect. Determine what types of data to collect. When conducting the initial baseline, start by selecting a few variables that represent defined policies. That's why I say you cannot factor in everything. It depends on the policies of the organization, your area of concerns or area of concentration. If too many data points are selected, look at it here, the amount of data can be overwhelming, making the analysis of the collected data difficult. So you need to be selective and be emphatic. Start out simply and fine-tune along the way. You can start small and keep on building as time goes on. Some good starting variables are interface utilization. This one is non-negotiable. You need to understand the interface utilization of your devices. CPU utilization, non-negotiable. These are data that you need to be aware of when you are doing your baseline. Step 2, identify devices and port of interest. I've mentioned that briefly. Major connections, you must capture all those ports. You must document those connections. A logical network topology can be useful in identifying key devices and ports to monitor. As shown in the sample topology, the devices and port of interest includes, look at PC1 because it belongs, is connected to the admin. The other two servers, because they are servers, that's why we're capturing them. Router interfaces, key port on switches. Now, when you say key port on switches, we're talking of switch to switch connection. Look at all the things that were captured here. Look at this port captured, this port captured, this port captured, captured, because these are connection to major other devices or server. So you need to capture those connections, and you can fine tune as you move on. So you need to identify devices and port of interest when you are doing your documentation or part of your baseline. Step 3, determine the baseline duration. When capturing data for analysis, the period specified should be at a minimum 7 days long. You cannot do baseline now and say, this is the behavior of my network now and forevermore. It can change. And the fact that it has changed does not mean something abnormal is happening. Take, for instance, somebody that is not a heavy user on the network today can become a heavy user tomorrow, burning down the network like crazy. And it's not because you are under attack. So you have to do your baseline like on a weekly basis. If you like, you can say every 2 weeks you want to conduct another baseline to see the performance of your network, or to still understand if the baseline that you've taken is still the way you have known it to be. But look at what they said here. It should last no more than 6 weeks before you conduct another one. Unless specified long-term trends needs to be measured. Unless specified long-term trends needs to be measured. You can decide to change that, but you can keep to best practices. Generally, a 2 to 4 week baseline is adequate. So you can say every month, I want to check these things out again. Every month, every 4 weeks, and so on and so forth. So it's not something you do once and for all and say that's all. Conduct an annual analysis of the entire network or baseline different sections of the network on a rotating basis. You sometimes can do a light baselining, or you can go in depth. You can do something regularly based on 4 weeks. There's some things you can do. You can travel in depth and dig deep, depending on what you are trying to achieve. For instance, now for people that do security, part of the thing they do is they launch vulnerability assessment tools to probably scan a segment of their network, maybe on a monthly basis, weekly basis, and so on and so forth. So it depends on what you are trying to achieve. Analysis must be conducted regularly to understand how the network is affected by, look at what I said, growth and other changes. You may have more networks, the network is being extended, more users on the network, or people that were not heavy users before are now becoming heavy users. So you must keep on conducting your analysis so that you can keep up. So look at some of the data measurements we can grab from our devices. All those commands we've showed you or we've gone through when we were doing the configuration. These are commands that can also help you to do your documentation. For instance, if I say show version, from the output of show version, I can see the display's uptime, how long my router has been up. I can see the version of the operating system. I can see details about the hardware. So if I want to do documentation about a router, my router, I need to get into the router and issue show version. That command will enable me to capture some information that I can document. If I say show IP interface for IPv4 or show IPv6 interface for IPv6, what will I see? It will display all the configuration options that are set on an interface. We've issued this command before. I can go down and say show interfaces so that I can see detailed output for each interface. I can say show IP route so that I can document the routing, the information that I have in my routing table, the directly connected and the remote. I can say show CDP neighbor detail so that I can document the neighbors that are directly connected to my routers. I can say show hub so that I can see my hub table. I can say show running config. I can see my running configuration file. Show VLAN to see the VLAN on a switch. Show port to see the status of the switch, and the last one here, show tech support, is used to collect a large amount of information using the multiple show command for technical support reporting purposes. I have never used this command before, but you can explore that. So all those commands we've been talking about that we have been using in the process of configuring our routers and switches, they are going to be handy when we are doing our documentation. So it's not just enough for us to use them to troubleshoot. We can also use them to do our documentation. Any question before we move on? Rest. Question?
No, sir.
Okay, good. Mac?
No, sir.
Okay. So let's continue. So now let's talk about troubleshooting process. What are the steps you have to go through when you are trying to do troubleshooting? Now, this thing comes with experience. That's why I say when I'm done with all this theoretical stuff, I will now talk from experience. This thing comes with experience, but let's learn from the book first. Book is good, but experience is the best. General troubleshooting procedures. Look at what he said here. Troubleshooting can be time consuming because network differs. Networks differ, problems differ, and troubleshooting experiences varies. Look at it here. That's the key. Using a structured troubleshooting method will shorten the overall troubleshooting time. That is the truth. If you have a structure you are following, it will reduce the amount of time you spend on the network doing your troubleshooting. There are several troubleshooting processes that can be used to solve the problem. The figure displays a logic flow chart of a simplified three-stage troubleshooting process. So let's check out this one. They said stage 1, gather the symptom. We're going to still explore them one after the other. Stage 2, isolate the problem. Stage 3, implement corrective action. So if the problem is fixed, is the problem fixed? If it is no, what happened? If he did not fix the problem, or if he created another problem, undo the corrective action and start again. The other side, if the problem is fixed, document the solution and save changes. So what do you mean as you gather symptoms? Let's check it out. So the first stage where they say gather symptom, I'm looking for something here. Okay, let me explain first in case I don't come around it. Like if you are not feeling fine now and you go to the hospital, the doctor will start asking you some questions. And the reason why they will ask you some questions is because they want to understand from the symptoms what you are, because it's not possible for you not to be feeling fine or to be sick and not have some symptoms. Say for instance, now if you have headache is a symptom that something is wrong with you. It's just a signal. It's a beep that is telling you, bros, you need to check out something. Maybe your BP, maybe you've not slept well, maybe you're overstressed, and so on and so forth. So you need to gather symptoms from the user. And unfortunately, most of the times the users can't help you. So you need to, that's where experience comes in. You need to ask questions like when did this first, is this the first time this thing is happening? When did it start? Has it ever happened before? All those kinds of stuff. But the problem is most of the time the users don't tell the truth, just like patients too don't tell the doctors the truth. If they have treated the malaria before coming to the hospital and they refuse to go, they will not tell the doctor they tried to treat malaria. You got to gather the symptoms. Then stage 2, you proceed to stage 2, you isolate the problem. Okay, since it doesn't have these symptoms, that means it cannot be this, it cannot be that, it probably may be this, it probably may be that. And based on what you thought is the problem, you implement corrective action. These are basic 3 stages, but we can go beyond that. Let's go beyond that. So they gave us 7 stages here. Number 1, define the problem. Number 2, gather information. Number 3, analyze information. Number 4, eliminate possible causes. Number 5, propose hypothesis. Number 6, test the hypothesis. Number 7, solve the problem and document the solution. So what are we trying to do? If number 1 is you need to first of all know what the problem is, because as long as you don't understand the problem or you don't know what the problem is, you would never be able to solve the problem. Once you know the problem, once you know what the problem is, you understand the problem, it is half solved already. So you verify that there is a problem. Make sure you verify that there is a problem, and then properly define what the problem is. So you define it. Number 2, gather information, targets, host, devices. You identify them, you assess them, and gather information. Because sometimes the users can tell you, hey, I can't browse the internet. The internet is slow. Are you the only one? Is it everybody on the network? You need to gather a lot of information. Or is it just that segment? And so on and so forth. Analyze the information. So you have to identify possible causes using your network documentation, using your network baseline, knowledge bases, or peers. You ask questions from people around you. Okay, when I've been going through this before and so on and so forth. Then you eliminate the possible causes. So you progressively eliminate possible causes to eventually identify the most probable cause. So you do your what do you call it? Elimination method. Then you can propose a hypothesis. When the most probable cause have been identified, a solution must be formulated. So you come up with a solution. Okay, let's try this. Or it could be this, or it could be that. Test the hypothesis. Assess the urgency of the problem. Create a rollback plan. That is key. It's very important. You need to have a rollback plan, because what if what the solution you brought to the table is going to further complicate the problem? So you need to have a rollback plan. Implement the solution and verify the outcome. If it doesn't work, you go back. But if it works, what do? So you solve the problem, inform all involved, and document the cause. Now, this one that they just mentioned here is a problem for us. Most of the time, when we solve problem, we don't document the solution, because we feel like, it's working. As long as it's working, we don't bother, we don't care to go and do documentation. But do you know that in the future, you can encounter similar problem and you'll not be able to remember what you did to fix the problem before? But if you have a documentation, you can just go straight to your documentation and say, okay, I've encountered this problem before. And what did I do to solve the problem back then? So you can read through your documentation and you'll be able to to use the information in the documentation to solve the problem. Question end users. You need to ask questions. I've mentioned some of those things before. Ask pertinent questions. What does not work? What exactly is the problem? What are you trying to accomplish? Determine the scope of the problem. Who does this issue affect? Is it just you or others? What device is this happening on? You need to ask all those questions. Determine when the problem occurred or occurs. That timing is very important. When exactly does the problem occur? When was the problem first noticed? Was there any error message displayed? You need to learn to ask all these questions. Determine if the problem is constant or intermittent. Is it a regular thing? Can you reproduce the problem? This is another problem. Most of the time, if the user cannot reproduce the problem, maybe by the time you go to the place, the thing is working fine again. And it was bad yesterday, it was bad an hour ago. As long as they cannot reproduce the problem, you can't help them. Can you send me a screenshot or video of the problem? That is key. Or you can say, okay, if you encounter that problem again, just call me immediately. All those kind of stuff. Determine if anything has changed. What has changed since the last time it did work? When it was working before, did you install any software? Did you change cable? You need to ask all of these questions. Use questions to eliminate or discover possible problem. It is most of the time from the question you know the answer, if you have the experience. What works? What does not work? So in your troubleshooting, in the process of troubleshooting, you gather information. Apart from you asking questions, they said it's not working. From the person's system, you can try to ping the internet. Let's say they are not browsing. You can try to ping the internet. If it is the whole network, you ping from your router. I'm still going to come to that. You can use traceroute command. You can use telnet. You can SSH into a router or a switch if you have SSH configured. And you can use all these our show IP routes, show protocols, just to do some troubleshooting. And those are some of the things I'm going to come and talk about briefly in my own way. Troubleshooting with layered model. So what are they trying to teach us here? The same OSI model we have been talking about. Talk about the flow of data. We can use this same layer to learn how to do troubleshooting. And they are telling us how to use this to do troubleshooting. We can start our journey from layer 1. When we're done, we're sure layer 1 is up and running, we move to layer 2. Layer 2 is up and running, we move to layer 3. Layer 3 is up and running, we move to layer 4. And of course, don't forget 5 to 7 are combined together, which has to do with application. So layer 1, layer 2, layer 3, layer 4 is where we reside as network engineers. Anything that has to do with layer 5 upward, That is the problem of developers. It's the problem of the programmers. As long as we are able to do our troubleshooting also to layer 4 and everything is up and running, then probably it's an application problem or browser's problem. Now, this one we have here is called what we call bottom-up troubleshooting. Bottom-up troubleshooting, because we are starting from layer 1. We also have what we call top-down troubleshooting. You start from the application layer and you come down. Top-down troubleshooting. And we also have another one called divide and conquer. Divide and conquer, you start from layer 3. From layer 3, you now decide whether you are going up or you are coming down. I don't think those ones are in this place. I learned those ones from CCMP. So 3 different ways of doing troubleshooting. You can have bottom up, meaning you are starting from layer 1 to layer 7. You can have top down. You are starting from layer 7 coming down. The best, or the one that people use most of the time based on experience, is divide and conquer. They start from layer 3. If layer 3 is working, they continue upward. If layer 3 is not working, then they come down. So from experience, you will be able to know what to do. But let's explore what they have in this place for us. So look at them. Wow, they are here. I didn't even know they are here. Look at them here. Look at different approach to troubleshooting. Bottom up, I just explained that. Top down, I explained it. Divide and conquer, I explained it. Look at others here. Follow the paths. Follow the paths. How? How? If I say, okay, I am going to I can't remember this. Maybe you guys will help me. When you are going to Accra, which other major city will you meet on the road before you get to Accra? Rex?
In Koko.
Okay. Let's say these are routers and this our destination is Accra. And these routers will lead us to Accra. And this is me in from where to where now? Let's say from Kumasi to Accra. Can we put that one?
Yes.
Okay. Let's say this router is in Kumasi. So now, if you ping from this computer here to this computer in Accra, and they cannot talk to themselves, ping is not going to show you where the problem is. Ping is not going to, it will just tell you, I tried to go to Accra. Unfortunately, I couldn't go. So you will just say request timeout. But when they are talking about following the path, you need to know from one router to another router, from one router to another router. Even if you have 1 million routers on the road, you need to know where your problem is. So we can go to another command that can show us that as I was on my way from Kumasi to Accra, I got to the second router successfully. But between the second router and third router, I couldn't go again. That is following the paths. You are able to eliminate the problem along the line. So you now know that you need to go to that router at that, I don't know, that CC that may call right now and troubleshoot on that router between that router and Accra. So you need to follow the path. So in following the path, you are able to isolate or eliminate where the problems are and able to solve the problem. Then you can troubleshoot by doing substitution. A cable that has been working before, all of a sudden they said it can't browse. Come in with a cable you know that you have been using that is working. A device that is no longer working, come in with a device you know that is working. Comparison. Attempt to resolve the problem by comparing a non-operating element with the working one. It's like you're following a model. Okay, what's the configuration that is on that router that is making it to work, or on that switch that is making it to work, and then you now follow and put on the ones that is not working. Educated guess. Success of this method varies based on your troubleshooting experience and ability. You can guess based on experience. Even though it may not make sense to some people, you may be able to say, based on this should work, and you move up. So now we have talked about different types of troubleshooting. What are the guidelines for selecting a troubleshooting method? To quickly resolve network problem, take time to select the most effective network troubleshooting method. So how do you know whether you're going for top down, bottom up, divide and conquer, follow the... Sometimes you have to combine all. That's my preference, is divide and conquer. When you start from layer 3, you first of all, I'll come there. That's my preference. From there, you know what you do. So when you define the problem, you know the type of problem, then you'll be able to tell the troubleshooting method to go for. For instance, if you discover that the problem is software related, it is advisable you start from top, because layer 7 has to do with applications. If you discover that it's hardware or cable oriented, you can start from bottom up, because you know layer 1 has to do with hardware, physical things. But if it is a new problem, you can do bottom up, or you can do divide and conquer. And I'm going to talk more on divide and conquer. I just say you start from layer 3. I'm going to illustrate to you how you are going to do all of this. Troubleshooting is a skill that is developed by doing it. You can't read it in the book. You can do the lab. That's why those labs I'm going to send to you are very important. But I did not send those labs because I'm not taught troubleshooting in like with the way we are doing it now. I've not really taken it as a chapter and explained it. That is why I didn't send those labs. But now, when we're talking about troubleshooting, we're going to be exploring that dimension. Every network problem you identify and solve, get added list to your skill share set, because it becomes part of your experience. It becomes your experience. You cannot buy experience. You have to own it. You have to find it. It has to become your experience. That is that on that part. Any question before we continue?
Sir.
Yes.
No, no, sir.
Okay. Mac,
No, sir.
are you guys flowing with me?
Yes, sir.
Okay, good. So let's still continue. Troubleshooting process. We need some tools. Apart from commands, some physical tools may help us out. So common software troubleshooting tools include the following: network management system tools. Like what? Network softwares include device level monitoring, configuration, and fault management tools. Tools can be used to investigate and correct network problems. Now, when you talk about network management system tools, they are plenty. Now, the most popular one out there is our PRTG, which is our network management tool. I talked about this when I was for one of the videos that I said you guys should listen to on network management. It can help us to do our troubleshooting. Knowledge base or basis can also help us to do our troubleshooting. Where are we going to get all this knowledge? Online. You can get a lot of knowledge online. If your network is behaving in a particular way you don't understand, you just search it on the internet. And from the word of experience that other people have gathered, they are nice enough to put some of this information online. Okay, this happened, I had this problem, and this is where I was able to solve the problem. That is another tool you use. Baseline tool. Remember, you have done your documentation. Your documentation is also going to be part of the tools you need in doing your troubleshooting. You check from the diagram, software, hardware documentation, everything you got, bandwidth usage, all of these things are going to help you to know that there's a problem, and then how do you resolve the problem. These are some of the tools. Another tool that is very popular out there that we can use to do our troubleshooting is protocol analyzer, and the most popular among them all is our Wireshark. Wireshark is fantastic in doing troubleshooting, but you need to acquire that skill on how you can use Wireshark to do troubleshooting. It's a software tool that we can use for our troubleshooting. What about hardware tools? This is what we use most of the time. Cable tester. How will you use your cable tester? They said, okay, I can't browse again. Is the problem with the cable? If you don't want to change the cable, just carry a tester and check. Uplink is done. There's a segment of the network or the organization are not able to browse again. Carry your cable tester and test. This guy is very important, extremely important. As simple as a cable tester is, it can save you a lot of headache because it has to do with layer one solution. It solves your layer one problem. It solves your layer one problem. Now there are other devices like digital multimeter, especially when you are troubleshooting to say, okay, is there power in the in your in the cable break? Is there power coming into the extension and all of those things? Cable analyzer, especially for people that use copper, is there? Can we send data from source to destination? I've never seen all these ones. I've seen this. I've seen this. I've not seen this one. I've not seen this one. I've not seen it. But the most popular among them or that we use most of the time to do troubleshooting is our cable tester. So these are our hardware tools to do troubleshooting. Syslog. I also talk about syslog in one of my videos that I said you guys should listen to. My logs can also help me to do troubleshooting. From my logs, I can determine, oh, on so days, this happened, that happened, and based on the information that I get from my log, I can solve the problem. It can help me or further help me in solving the problem on my network. That's why you don't take your log for granted. You need to make sure that your log is up and running, or running on the router, or running on your switches, and make sure you offload them on your syslog servers. So I think this should be the last part, if I'm not mistaken. So symptoms and causes of network problems. So what are the things that could cause problem on the network? Most of the time, it could be hardware problem, it could be software problem, it could be users problem, or maybe virus, or you are under attack. That is why you need your baseline documentation. So the physical layer troubleshooting, what are the things you could solve there? Anytime you hear physical layer, it just has to do with physical things, the cable, the network port, the router, the switches, everything physical. So you could run into a lot of trouble and you should be able to fix the problem. So let's go through this. Performance lower than baseline. So you see that your baseline, something has gone wrong with your baseline. The performance of the network is not as it used to be. So what do? You do comparison, what you are getting and what you got before. The most common reason include overloaded or underpowered users, unsuitable switch or router configuration, traffic congestion on a low capacity link, and chronic frame loss. So it's a layer one issue. Maybe the bandwidth you are using before is 2 meg and the network has increased and you need 10 meg or you need 20 meg. You need to, from there, you'll be able to decide or the reason why your network is performing lower. And of course, loss of connectivity. If you have connectivity issue, you verify that from your ping, and that could be because the cable is disconnected, and that is why you're losing connectivity. It's a layer one problem. Network bottleneck. When you have bottleneck, most of the time is because the network has increased or grow. The network has grow, and the bandwidth is no longer enough, or you are under attack. High CPU utilization. Of course, if you're under attack, your router will overwork than before, or you are not under attack. Maybe you have a switching loop on your network. The router will overwork than before. And then you can also have console error messages. These are all layer one problems. So, and these are all you can solve. So, still talking about layer one troubleshooting. So, how do you solve most of these problems? Check power related. If it is power related, check the operation of the fan and ensure that the chassis intake and exhaust vents are clear. Let me use your laptop for example. If you notice that your laptop is generating too much heat, if you need to find out, is the fan working? The same thing with these routers and switches. Hardware fault. Faulty or corrupt NIC drivers, bad cabling, or grounding problem can cause network transmission error, such as late collision, short frame, and jabbers. So what we're talking about. Maybe it's just somebody's computers you are trying to troubleshoot. I'm not browsing. Everybody is browsing, and their network is very fast. Mine is not fast. It could be a network problem, network card problem. Check the drivers. It could be a cable problem. Change the cable. If you're suspecting the cable, pimp another one. Attenuation, that means the cable probably is too long or is getting tired, and so on and so forth. Noise also could cause problem for us at layer 1 when you have electromagnetic interference. Nowadays, we don't really have this problem because of the type of cable we use nowadays. They are able to withstand noise, all these Cat 6, Cat 6E, and so on and so forth. Interface configuration error. If you configure some interfaces on your router and there are issue, check all of these things. It could be clock rates, it could be some settings that are not correct, exceeding design's limit. You have gone beyond what you are supposed to, the numbers of devices you are supposed to link together. If you don't have a good design, you can run into trouble with that, with your design. CPU overloaded. What will make your CPU to be overloaded? If the traffic is too high, the router or the switches can be processing at a very high hit rate, and that will also affect the performance of your network. Then we have layer 2 troubleshooting. Most of the time when you talk about layer 2, let your mind go to the switches and even network card. So when you have problem at layer 2, what are the things you need to talk about? What are the things that we normally do on our switches? The protocols we run or the technology we run like that can give us problem. Take for instance, spanning tree. If there is a loop on our network, you know that that's a layer 2 issue. Switching loop is a layer 2 issue. And that could make our network to slow down or reduce in speed because of excessive broadcast or multicast on the network. And the frame that will be going from source to destination will have suboptimal path to their destination because of the unexpected high bandwidth usage on the network, probably as a result of switching loop, or people are too much now. The network has grown. So anytime you hear the data link layer, let your mind go to the switch and the technology that runs on the switch. It could be an encapsulation error. Now, we didn't really talk much about encapsulation because Cisco does not really place, they don't make noise about encapsulation again nowadays. Encapsulation is just a way of formatting your data before it starts traveling. We have at layer 2 the way we encapsulate, and we have at layer 3 the way we encapsulate, different types of encapsulation. And of course, I've talked about it could be STP failure or loops. It could be frame error. It's difficult to have frame error nowadays because most of the time our switches are running on full duplex. We don't have frame error again. So these are different problems we can have at layer 3, at layer 2, and they can all be resolved based on understanding and experience. What about layer 3? Network layer is layer 3. I believe we know all these layers by number. That's why I'm not mentioning them. So what are the issues? When you hear layer 3 or network layer, your mind goes to the router. Your mind goes to IP address issue, subnet mask issue, default gateway issue, DNS issue, address issue. These are all the problems that we can have at layer 3. So anytime you want to solve layer 3 problem, your mind should go to the router, IP addressing stuffs, and so on and so forth. And I'm going to talk about some of those ones in my own way. So, and I'm still talking about layer 3 issue. Even routing table, say layer 3 issue. If I can't reach a particular destination, do I have that destination in my routing table? If I don't have your destination in my routing table, then I can't reach that destination. These are things that will enable me to solve my layer 3 problem. Okay, who's my neighbor that is supposed to take me to that destination? Can I even see that neighbor? I can go through my show CDP neighbor detail to check if I can see the neighbor. Do I have connectivity to the service provider? If it is internet issue, these are things that I may have to look into. So when you are troubleshooting layer 3, a lot of things to be considered, especially routers, IP addresses, stuff. But when it comes to layer 4, what do we need to consider here? The main guy at layer 4 is our access control list. People are not browsing, or somebody is not browsing. Is the person being blocked? Is it being filtered? Is there a configuration, a misconfiguration on the router that is blocking that segment or blocking somebody on the network? These are things that we consider at layer 4. So layer 4 simply has to do with maybe firewall is blocking something. So when you are troubleshooting, you don't rule out that part of troubleshooting also. So you consider other parts. So could be the main thing there is access list layer, and then NAT also is at layer 4. Are we doing our NAT properly? NAT is at layer 4. Is the NAT properly configured? So you may have to check the configuration of your NAT to be sure that your NAT is properly configured. It's supposed to be NATing. Check your NAT translation table to be sure that your NAT is working properly. And after layer 4, we fly to layer 7 to see the applications. So we can test run some application. As long as I can telnet into a server, it's no longer my headache, it's the headache of the developer. As long as I can test run HTTP, there are different ways to test run these things. It's no longer my headache again because these are layer 7 application layer protocols. So once I can hit that layer 7, I can test the layer 7. I just call the developers, the programmers on my network. Guys, this is not a network problem, it's now your problem. And so there are different ways we can test run all this. So we can test our FTP, TFTP, SMTP, POP, SNMP, DNS, and NFS. There are different ways to check this for us, we network engineers. And as long as we're able to check these things, we know that we are good up to layer 7. It is now the software problem if there's still a problem on the network. So how do you troubleshoot this connectivity issue? If you are going from bottom or up approach, where there is no end-to-end connectivity, number one, they say check physical connectivity at the point where network communication occur. Check for duplex mismatch. You don't have this problem again. All our routers and switches by default, they run on full duplex. Number three, check data link and network layer addressing on the local network. That is like you're checking your switch and you're checking the IP addressing issue. Number four, verify that the default gateway is correct. Number five, ensure that devices are determining the correct path from source to destination using our trace route. Number six, verify the transport layer is functioning properly. Make sure that the NAT is configured properly. Make sure your access list is properly configured. Number seven, verify there are no ACL blocking traffic. Number eight, ensure that the DNS settings are correct. These are different ways you need to test run or troubleshoot your network. So where is our tools? What are the tools to use to solve the problem when we're starting? Ping and traceroute. So our ping and traceroute can help us, and I'm going to expatiate more on that briefly when I go to my own topology that I want to use to explain some of these stuffs. So in troubleshooting IP connectivity, when I go to my router, what are the things I can look for? I can issue this command: show interface, then check a particular interface. What am I looking for? I want to check these interfaces on my router, the input and output. Do I have congestion on those interfaces? If I have congestion on those interfaces, that probably explains why my network is slow. Do I have errors on those interfaces? Error input error or output error? And I can check that. And what will make me to have input error or output error is if I have duplex mismatch. The device I'm connected to probably is running on a half duplex. I am running on full duplex. I believe you guys know the difference between the two. Half duplex and full duplex. Rex, do you?
So
Mac,
you said
do you know the difference between full duplex and half duplex?
Yes, sir.
Okay, good. I just want to be sure so that I don't just assume. So these are things I may have to check on my interfaces. So if I want to check for duplex mismatch, you see, here is full duplex, here is half duplex. That can give me input error and it can also give me output error. But nowadays, all of these devices run on full duplex. So, but in case one side is running on half duplex, you can move it to full duplex with this command, duplex auto. Verify addressing on the network. We have used this command before when we first started to see the mapping of IP addresses and MAC addresses of computers on the network. Verify VLAN. Okay. The import on the switch or on the switches in correct VLANs, and Look at your command here. From show MAC address table, you can find out which computer with a particular MAC address is in a particular VLAN. Like this guy here is in VLAN 1. This guy here is in VLAN 10. If it's not correct, you fix the problem. Verify that we have correct default gateway. If you don't have for correct default gateway, you can get out. Okay. If it is IPv6, the same principle applies to IPv6. And verify correct path. Are we taking correct path to the destination? If we are not, we may have to decide to change our route. Verify the transport layer. How do you verify the transport layer? Don't forget I said layer 4 has to do with access list and NAT. If you telnet to a particular router and switch, and the telnet is successful, that means you don't have a layer 4 issue because you're able to hit layer 7. That's another way of troubleshooting. So verify access list. How do you verify your access list? You should show the interface access list, interface serial, then the interface you say include access list. You can see if your access list is blocking something or it is configured or not configured. You can verify your DNS from your, what do you call it? ipconfig/hall. You can check your DNS. Even on the server too, on the router rather, you can check if the router can ping your Google's DNS. That is why most of the time when we start troubleshooting or internet troubleshooting, we want to find out if our router can ping Google. If you cannot ping Google by name, can it ping Google by IP address? Because before the Google will be translated to name, DNS has to be intact. So if I'm able to ping my google.com, I know DNS is not working. But if I'm not able to ping google.com and I ping Google by Google's DNS by its IP address, then I know the problem is my DNS. So let's go my own way. And I'm not configuring. I just want to draw a simple topology and then explain some things to you. Any question before I get there?
No, sir.
Mac?
No, sir.
Okay. Rex, sorry, I wanted to say Rex.
No, sir.
So let's pick one of the topology we've once worked with. Remember, we were working with two routers before. We said this one is in Accra and this is in Kumasi, if I still remember. So there is a LAN here, another LAN in this place. There will be users here. Let's say this is PC, PC here, PCB. Now the internet connection, I think we put, am I correct? Is this the design we had before? This router is this router the Accra router, the one on the left? Hello? Hello guys?
Sir.
Is it correct?
Is it Kumasi was on the left?
Okay, let me get rid of it. I want to put Kumasi on the, I want to, okay. So this is Kumasi and this is Accra. Now don't forget, we got internet connection injected into Accra router so that we distribute it to Kumasi, and we use OSPF to do that distribution. So now let's try to test for connectivity. Let's assume we ping from a computer here in Kumasi to a computer in Accra and the journey was not successful. What are the things we need to check for? The journey has to start from this computer here. This computer here that is not going to Accra, does it have an IP? Is it even physically connected to the network? Now that one you can see from the link lights on the ports of the computer. If it's blinking, You may eliminate layer 1. You may eliminate that it's not a cable problem. But from your computer, the icon, the LAN icon on your computer, you see connected or something like that, you eliminate that. That's not a layer 1 problem. So the link light is also something we use to do troubleshooting. The link light on our computer. What if this link light doesn't come up? I may be suspecting layer 1. That probably there's a problem with layer 1. So what could be the problem? Is the problem with the cable, or the problem on the port of the switch, or the problem on the port of my router? I mean my computer. These are all the issues. So I can bring in a new cable and test run it. That I'm sure is that a new cable that is working. I can change the port on the switch and all of that. But let's assume the cable is working, and I've eliminated that. It's not a layer 1 problem based on what I've seen. There's link light. The port is blinking. I can go to this computer, just put my IP config / all, or start with IP config first. What am I looking for? Do you even have an IP address? And if you do have an IP address, is it a correct IP address? Do you have correct subnet mask? Do you have a default gateway address? Do you have a DNS address? All of these addresses must be on this computer. So now that I went to the computer, go to my command line and put ipconfig / all. I am troubleshooting now at layer 3. That is a way of doing divide and conquer. I want to decide whether I should continue up or I'm coming down. So if I issue ipconfig / all on this computer and there is no IP address, why won't there be an IP address? Sometimes the user probably use their computer at home and they change the IP address to static for whatever reason to do some things. So from the output of ipconfig, you should be able to tell whether that computer is getting an IP address automatically or it is static. Do you know how to identify that from ipconfig environment, from command line environment? If the system has an IP address, how will you know whether it got it through DHCP or not? Do you know how to identify that?
No, sir.
Okay, let me show you guys.
Okay, sir.
Let's go there. So let me launch my command prompt. And share the screen. Can you guys see my command prompt?
Yes, sir.
Okay.
Okay.
So now let's check the IP address on my computer. I am browsing through wireless through a GSM router. So definitely the router will give me an IP address. So let's check. Look at, this is my wireless power LAN. This is my IPv4 address. This is my subnet mask. This is my default gateway. But the information I want to show you guys cannot be seen from the output of ipconfig. So let's go to ipconfig spacebar / all. This will give us more information. This is what I want to show you guys.
Oh, okay, sir.
If a computer has been configured to obtain IP address automatically, and it gets an IP address, it will indicate that this address that I have, I got it automatically from DHCP, or DHCP is enabled on that system. But if you use issue ipconfig and you don't see DHCP enable, and the system still has an IP address, it means somebody has given that system an IP address statically. And the IP address that will be given statically may not be in the same range of the address of that local area network. And therefore, it cannot go out, it can't be NATed, it will not be in the routing table, and so on and so forth. Is that clear?
Yes, sir, it is.
Good.
Sir, mostly what I do is that I go to the network settings and then check at the IP version 4
Yes,
whether it has been given a status.
that is you mean from the control panel?
Yes.
Okay, let me go there and show you that one too. That one is also good. Let me just share my desktop and some files so that you guys can see everything too. So can you see my control panel now?
Yes, sir.
You can't see my control panel.
Yes, sir, we can.
Say
Okay,
again.
okay, you can see it now.
Yes, sir.
Okay, now if I come to this wireless now and click this wireless option here now, from these details here, can you see these details? I can see also that DHCP is enabled. And this, now I will see the IP address, the IP details of this particular computer. So either way, you just need to be sure that that computer is picking IP addresses automatically, not statically. That is one of the reasons why sometimes some computers cannot connect to the internet, because the IP address that the user probably give is not configured to be NATed. And so that address cannot go out. Am I communicating?
Yes,
Okay.
sir.
So now let's assume this guy has correct IP address, correct subnet mask, correct default gateway, correct DNS address. Okay. Now why can't you go to the other side? We don't even need DNS for the guy to go to the other side, because we are talking about LAN to LAN communication. All right. Can you ping your gateway? So we may have to ping the gateway and see whether the guy can go out. Okay, let me go back again. What if this guy doesn't have an IP address at all and DHCP has been enabled? Maybe the DHCP server on the network is down, or the router is not dishing out IP addresses. So I may have to confirm other computers on the network, do they have IP addresses? If they do, then I know the problem is with this computer. Because I have seen a situation where a computer on the network will not pick IP address and the others are picking. So it's not a DHCP problem, it's that computer's problem. And most of the time, all you need to do is just to restart the network card, enable the network card and re-enable it. I mean, disable the network card and re-enable it again. That will fix the problem. Or just restart the system. But I've seen a scenario where and nothing works on that computer until we formatted the computer and reinstall the computer. Sorry. Sorry, guys. So now, so you may have to suspend the DHCP server, or you go and check if it's the system. But if it's everybody on the network, you know there's a problem with your DHCP server. But let's assume everything is good. You ping this gateway. If the gateway is responding, you know that, okay, this guy can get to the gateway. Well, what if the gateway is not responding? That probably could be the reason why this guy can't travel out of the LAN. But if the gateway is not responding, you have to find out, does this router has the correct IP address, correct subnet mask? Is the interface enabled? You check that. If it's enabled, okay, you continue. These two routers that are connected there, can they talk to themselves directly? You troubleshoot this interface, Then if it is successful, okay, why are we not seeing this LAN in the routing table of this router? Have we configured our routing properly? If you configure the routing properly, don't forget that communication is a two-way thing. Does this router know how to reply back? Or this interface that links to that LAN, is it up? Or even the computer we are trying to reach does not have a correct IP address, or does not have a correct subnet mask, or does not have a correct default gateway. The same troubleshooting you are doing for this guy here, you may end up doing for this guy on the other side. So these are different things you are going to explore to make sure that you have end-to-end connectivity. So you explore layer 1, you explore layer 2, you explore layer 3, you explore layer 4. That is just LAN to LAN connection. What about the internet? Most of the time, the problem is maybe the NATs or your default routes. Is the NAT working properly? Is the default route working properly configured? All the service provider is down. Let me add another problem. That should have even made the first. DNS server is down. There's no DNS. This is how you do your troubleshooting. But all of this comes with experience. This thing I am explaining to you guys now, I did this explanation for Kunle. Fortunately, when he went for the interview, they asked him some question about troubleshooting like this, and he nailed it. He was very happy that I explained these things to him. He nailed it. The only thing he missed was they asked him, okay, if you want to see DNS address on the computer, how do you see it? He kept on saying ipconfig. He should have said ipconfig/all. That was the only thing he forgot. But every other thing they asked him, he nailed it. So this is just my own way of summarizing troubleshooting from experience. So you must make sure you find out is it a general problem or one person's problem. If it's a general problem, maybe it's an internet problem generally, suspect your service provider, suspect your router in the server room. If it's one person's problem, suspect that person, the IP details or cable or layer 4 or firewall blocking that person. You must just know how to isolate, differentiate between a general problem or a personal problem. If you're able to get this done, you are going to be good with troubleshooting. Any question?
No, sir.
Rex, any question?
No, sir.
Are we good with this?
Yes, sir.
Good.
Yes, sir.
Good. All right. So if you guys don't have any question, so that will be the end of the class on troubleshooting. So I'm going to send
Okay, sir.
the labs that has to do with troubleshooting of all these things we've done. So now, now that we're ending the class today doesn't mean we cannot meet again. If you guys are doing any of the labs, you have issue, can just message me. We can arrange a class like this and trash them out. Until you write your
Okay, sir.
certification, I am still going to have to be giving you support. So, but first thing first, do all these labs, listen to all the videos, and then make sure that you master all these things.
Okay, sir.
Then
Thank
for
you
for
very much.
troubleshooting, there's a video in the CBT nugget I want you guys to listen to. I will send those the folder number later. The way the guy
Okay.
did the troubleshooting there and demonstrated is just fantastic. I want you guys to listen to those ones.
Okay, sir.
All right. So we'll be talking online if there is anything we need to talk about. This brings us to the end
Okay,
of
sir.
how many months journey?
Uh, is it 8?
8. No, this must be more than 8 weeks. We spent more than 2 months now.
Yes, sir. I think it's 9 or 10.
Rex, this how many weeks altogether?
Tell me, as for me, I'm not good with calculating.
I think we spent almost 3 months. I will check when we started the class.
Okay, sir.
Yeah. All right. So you guys should please brace up. Use this month and next month to do labs, finish everything, and then prepare for certification. So by the end of this month, I will send you the dumps to start preparing for certification. So next month you should be thinking of you setting the ball rolling for certification. So this month that we are in now, you should cover up all your labs because we are not having classes
Okay, sir.
again. All right, guys. Good night.
Okay. Yes, sir.